So now that we know why nonlinear devices are important, now let's talk about some of the problems that we might face while dealing with nonlinear devices. Well, as you know, nonlinear devices have nonlinear IV. Their IV curve might look like this, an exponential first function, or it can be like this. So these devices produce nonlinear equations, right? While we are solving circuit, while we are solving any circuit, these devices produce nonlinear IVs. So solving circuit means finding the I and V for all circuit components. So, but so here's the thing: the solving linear equations are very easy. If you have a set of linear equations, there are some pretty simple rules you can follow, and you can even solve them by hand. However, nonlinear equations are very hard to solve, and they require much computational power to solve such nonlinear equations. For example, say I have a set of linear equations and I am asked to solve them, find the value of x and find the value of y. So, so it's a pretty straightforward equation. What I can do is um, from equation 2, I can see that x equals 1 plus y, right? And from equation 2, and I can replace this value of x into equation 1. Then I will find that 1 plus 2y equals 3, and from this I can find that y equals 1. And if I replace the value of y here, I will find that x equals 2. So the solution of these two set of linear equations is x equals to 2 and y equals 1. Well, there is a graphical way to represent this solution, right? We can represent this as like this. This line represents the first equation, x plus y equals 3. And this line represents second equation, x minus y equals 1. So what does the solution represent here? What do we mean by when we say the solution is x equals 2, y equals 1? Well, it's the intersection point of the two lines, right? Say, as you can see, it intersects at 2, 1, this point. That's why we say that the solution of these two equations is 2, 1. It means that these two lines intersect at 2, 1 point. Okay, so this is pretty straightforward, right? Solving linear equations is pretty straightforward. But what about when you have equations in this form? X plus y equals 3. This one is a linear equation, right? This one is the same equation as the before. But this equation is not linear. Y is equal to e to the power x. So what can we do? Well, we can try substitution. For example, from equation 1, we see that y equals 3 minus x, right? From equation 1, we see y equals 3 minus x, and we can replace the value of y in equation 2, and we will find that 3 minus x equals e to the power x. Or we can rearrange and find that x plus e to the power x equals 3. Now the question is, how can we solve this equation? Actually, there are no simple way to solve this. I mean, we can try this graphically, right? Well, again, this line represents first equation, x plus y equals 3. And now this line represents the second equation, y is equal to e to the power x. So what do we mean by solving these equations? It means that we have to find this point, and from the graph we can see that it's approximately 0.9 comma 2.1 or something like that, but we don't know the exact solution. So if we want to find out the exact solution, that's very hard, right? Because this equation cannot be solved using some algorithm that we have already known. There are two ways, actually. There are two ways to solve these types of nonlinear equation. One is the graphical way. We plot the graphs of the equation and we find the intersection point. Or there is another way, which is called, which we have already studied, numerical method. But there is a problem with numerical or graphical methods. They are very slow. They are very slow, right? And they are very hard to solve by hand. We cannot solve them by hand.